network that actually solves a problem that we've experienced before in the crypto community. I want to talk about a high-level definition of how the Lightning Network works. Is most people in here, can you raise your hand if you've done a little bit of coding before? Okay, it looks like the majority of people have done at least a little bit of coding. So I'm not going to get like really low level on the Lightning stuff, but it is important to kind of understand how it works and why it is a longer-term viable solution. And then we're also going to talk about problems with Lightning. So Lightning is still very new technology. There's a lot of hype behind it, and a lot of people are very excited about Lightning, but that doesn't mean that the current state that we're in with the Lightning Network, it's not perfect. And it's not going to solve, all of the world's problems and, like a lot of people sell cryptocurrency solutions as. Oh yeah, so like the key point I think is very important to acknowledge as somebody that's, been in blockchain development for quite some time now and kind of understands how these things work at a really low level is like blockchains suck. They are good for a very limited specific thing, and that's kind of converging on what the state of a system is on a longer time frame. So, as I kind of enumerate here, like they're very slow because coming to consensus on who has what in this ledger takes time. Depending on who you are in the network, let's say you're in Korea versus you're in the United States, depending on how fast your internet traffic is, you may think the blockchain is in different states. So, and what that really means to the end user is, I don't know who has what money, and then I cannot trust or accept payments from these people because I don't know what the state of the ledger is. There's conflicting views here. And blockchain, or Bitcoin specifically, on a very low time frame doesn't solve that problem. What Bitcoin's good for is converging on consensus on a longer time frame. Blockchains are really inefficient too. The architecture of a blockchain means that everybody has to know everything about everyone at any given point in time in the system. So I think Paul, I don't know if Paul's in here or not, but he had a bit message example earlier in the talk, and what was going on with Bitmessage here was everybody had to be receiving everybody's message all the time, and that's just inherently inefficient. So I don't need to know what people in China are talking about amongst themselves if I'm not talking with somebody from China directly. And the way blockchains are set up is so that I need to know what's going on in China, I need to know what's going on in Antarctica, I need to know what's going on everywhere, because I need to know if they have money and if they're breaking the rules of Bitcoin or trying to inflate coins or just not following the rules more or less. So it's very important with the blockchain, you know what everybody's doing so you can validate that they're not breaking the rules of the system. Yeah, and then so like because you have this this limitation where you need to know what everybody's doing and everybody needs to share the same ledger, you're going to inherently end up with this trade-off of do we try and maximize decentralization of the network, which means that we need to limit how much resources need to be used to run the network, or we can really hotwire this network for a lot of stuff happening on the chain, but what that means inherently is less people are going to be running the network, so you can see a little bit, or less people can validate that everybody's following the rules. And you kind of see this trade-off with Bitcoin and Ethereum. Bitcoin has taken the approach of trying to minimize the amount of resources you need to run a Bitcoin full node, whereas Ethereum has tried to shove more stuff into the blockchain and provide more functionality at the base layer, but this just means less people can actually validate that everybody's following Ethereum's rules at any given point in time, and you kind of end up with this more of a centralized effect of Ethereum node operators. Another kind of inherent limitation to blockchains is that it's really hard to maintain privacy on them. Bitcoin, the story with Bitcoin is bad, the story with Ethereum is bad. You have other coins that bill themselves as like privacy-centric coins, but even using those coins, you give away information about what you're doing on the blockchain at a given point in time. So for instance, just like what time a transaction happened, like yeah, so like what time a transaction happened, for example, is information that people can use to deduce behavior about you. And then like, what do I think blockchains are good for? Is settlement. Again, going back to the longer term convergence of state here. This is what blockchains are really good at, and this is what the point of proof of work is. We have these miners all around the world expending a bunch of energy to try and prove that they, or get rewarded with Bitcoins and prove that they verified what's going on this blockchain. And again, this can be wrong on shorter time intervals, but over a long time frame, you get this convergence of what's happening and who has what in the system. So, like, I just talked a lot about blockchains, and this talk isn't about blockchains, but it's very important to understand what the blockchains are good for, and then like how we can build a protocol on top of a blockchain to kind of take advantage of what blockchains are good for and supplement what they are not good for at the same time. So in 2016, the Lightning Network was kind of conceived. It was conceived by these two guys named Taz Dridja and Joseph Poon. They came out with a paper. It's a long paper, and there's been modifications done to it since then. The Lightning Network, as it currently stands, isn't exactly like what was talked about in the paper. But like, their hypothesis was kind of what I just said. You need a layer above a blockchain, and you need to use these kind of immutable characteristics over a long term to your advantage. A key difference from an architectural point of view between a blockchain and the Lightning Network is that, again, going back to blockchains require you to send messages to everybody at every given time, and like in the technical parlance, we call this a gossip network. So that means I'm gossiping about what's going on the blockchain constantly with all of my peers. I'm sending them information about everything that's happening. Maybe if I just saw a block on the blockchain, or a miner found a block and I just saw it, I need to tell all my peers about that. If I just saw a transaction, I want to relay that to all of my peers, just so we can all come to this common state again, and come to consensus on what's happening. With the Lightning Network, this is a little bit different, because not everybody is interested in everything that's happening. This architectural change here means that I now only care about transactions that are directly related to me. And again, I don't care about what people are doing over in England, let's say, on the Lightning Network. I just care about if they're directly interacting with me and giving me money or sending me money. So this allows you to have a lot less resources needed to run a Lightning node. You don't need the 250 gigabytes of disk space that you need to run Bitcoin. You probably need more on the order of a couple of gigabytes of disk space. So yeah, that's a fundamental difference here between Lightning Network and blockchains. But it's not all wine and roses in that regard. With Lightning Network, you're inherently passing around these unconfirmed transactions. So going back to this coming to consensus over a long period of time, what blockchains are good at. With the Lightning Network, you're kind of circumventing that consensus mechanism. So what do we do to kind of set up the game theory to make sure that people aren't stealing your money? Is like creating these things called penalty transactions. And it's a way to ensure you set up these incentives so people aren't broadcasting old states on the Lightning Network. Okay, I've said a lot here, moving pretty quick, and I forgot to say this at the beginning. This is all very, very new technology, and I'm open to questions as we're going along. I'm kind of blowing through these slides, and this is a very difficult technical matter, and there's no stupid questions when it comes to this stuff. A lot of people, I think, in the blockchain space kind of hand wave things away and don't actually get down into the nitty-gritty details of why a piece of technology is long-term sustainable and why it won't blow up in your face in a year or two. So I just want to make sure I encourage questions. So as we go along here, and especially as we get into kind of how the mechanical things of the Lightning Network work, people feel free to ask questions and I can answer those at any point in time. And yet, one of the most important things about Lightning is it's using simple smart contracts that are widely understood by everybody in this space. Jameson didn't talk about this actually in his last talk, but there's been a lot of funds lost from smart contracts being written poorly. And now you end up in this like weird political situation that Ethereum ended up in 2016, where you had to decide whether to bail out owners of a smart contract or not. The Lightning Network uses very simple smart contracts that are widely understood by everybody that have just a few key cryptographic primitives that are used. So the Lightning Network is a series of channels. You can think of, like, the example people usually give here is, like, you can think of a channel like a mnemonic tube. You know, in the movies, I'm not old enough to actually seen this in practice, but I've seen it in movies before. Like, people would transfer mail inside of buildings by putting like a tube with mail into like this, like, putting a little capsule, I guess is the best word for it, into a tube, and then it would like go wherever in the building and end up in the right place. So Lightning's kind of like this. You have channels open with your peers that are kind of like these tubes, and what you transfer over these tubes is money. So to open a Lightning Network channel, the very first thing you need to do is like find somebody you want to open a channel with. And opening channels with strangers probably isn't the greatest strategy for success because, again, this is a network that anybody can do things on at any given point in time. So they can maybe do malicious things to you that won't cause you to lose money, but may force you to not have access to your money for a certain period of time. So you want to go find somebody that you're fairly confident and is reputable in the community that you think will be a good peer on the network and will send your money when you want to send it, and you can relay their money when they want to send money too. So step 2 is the Lightning Network is inherently tied to at least one blockchain. So it's a full reserve system, so that means for every Bitcoin that's on the Lightning Network, there has to be a corresponding Bitcoin locked up on the Bitcoin blockchain. So in the process of setting up a Lightning Network channel, the next step after you find a peer that you want to open a channel with is to tell them how you are going to fund this channel. So you need to prove to your peer that you have the money that you want to lock up on the Lightning Network, and then you need to show them where that's at on the blockchain. So step 2 is complete. We've now found somebody that we want to open a channel with. We told them that we have the money we claim to have. Here is a very critical step in the process of setting up a Lightning Network channel. If you didn't follow step 1 carefully and, like, you know, peer with somebody you like or somebody that's reputable, you end up in this situation where your peer can disappear and you have your money locked up on the Lightning Network forever, and you can never redeem it. You are just kind of left having your money stuck in this smart contract. So what we've done in the Lightning Network to get around this is we have a stipulation when setting up a channel. It says that, like, hey, if, you know, this guy that I'm peering with on the Lightning Network, the guy that I'm opening a channel with, if he just disappears into thin air, I can get my money back after a predetermined amount of time. Let's say it's after, if he just disappears for 48 hours, I can now redeem my money via a branch in this smart contract. So this gets around the problem of some guy just disappearing and leaving you holding, you know, Bitcoin that you can't actually spend. So we've gone through step 1, 2, and 3. We're ready to actually make a Bitcoin transaction and send it to the blockchain so we can formally open up this Lightning Network channel. So we've gone through the steps to make sure we can't lose money as the funder of this Lightning channel, and now we're ready to actually get into the Lightning Network. So the process of broadcasting this transaction to the Bitcoin blockchain allows us to take the first step of having people on the Lightning Network acknowledge that you're trying to open a channel. So we broadcast that funding transaction. We wait for the Bitcoin confirmations, which is a parameter that can be set by you and your peer. I mean, I usually recommend 3 confirmations to make sure that something bad can't happen and your channel gets reorged out from underneath of you. And then step 6, channel's open. We can now send money over the Lightning Network. And of course, like, all of these steps are automated away by wallet software, so you won't have to do any, like, manual interaction here. But it's important to understand, like, why this works, and then, like, what measures we've taken as Lightning developers to keep money from being stolen from you. So this is, you know, channel 1 or transaction 1. We've got a channel open now. We're ready to transact on this network. Yep. Yep. So step 3 here is get your peer to give you a digital signature, and what that digital signature says is they are giving you a digital signature that says, in case they disappear in the future, you can use this digital signature they gave you to redeem your money via the timeout portion of the contract. So again, and that's like why you get this guarantee of like, hey, like if you disappear from the Lightning Network, you vanish off the face of the earth. Well, I've got to go through this kind of annoying process of waiting, but I know I can get the money back at the end of the day. So that's very important. What's up? Yes, exactly. So if I have with this with step 2 here, this output has a certain amount of money in it. So let's say if it has 1 Bitcoin, like I can't transact 2 Bitcoins there. So or if it has 0.1 Bitcoin or 10 Bitcoin, So yeah, that is like an upper limit of like what I can like have for channel capacity here. You can. Sort of, I guess. I mean, like, yes, you do have it preloaded with a certain amount of money, which is the UTXO that you funded the channel with on the blockchain. And there's protocol enhancements that are kind of being talked about right now to get around that, so you can top off the channel with even more money, like while the channel's operating. But that's a little bit more speculative. And then in this talk, I'm trying to just kind of talk about like what the Lightning Network is today and like what you can do today. So like, now that we've opened this channel, like we're ready for like normal operations on the Lightning Network. And like there's this like key smart contract in the Lightning Network, and it's called the hash Timelock contract. We abbreviate that with the term HTLC, so I will probably use the phrase HTLC going forward, but just remember that it stands for hash Timelock contract. And as the name kind of indicates, there's 2 spending stipulations in a HTLC. You can either know the pre-image to this hash and spend the funds successfully, or you can wait for the time lock to expire and spend the funds successfully. So there's 2 ways to spend money from an HTLC. And then like inherently, if I'm offering an HTLC to a peer of mine, they can like claim this money by revealing the pre-image to a hash, or I can get my money back by just waiting X amount of time. And like these are the kind of fundamental unit that are used to transact on the Lightning Network. So this is like a lot of like text here, but it's important to like just understand like how this works conceptually. We're going to pretend like there's 3 people on the Lightning Network. There's Alice, Bob, and Carol. Alice wants to pay Carol, but Alice does not have a direct connection to Carol. So going back to the theme that the Lightning Network is a routed network, you do not have to be directly connected to your counterparty to be able to send them money. So in this example here, you can pretend like Carol is like Coinbase. Like Coinbase, very large Bitcoin company. Let's say they were to adopt the Lightning Network tomorrow. Everybody's going to want to connect to Coinbase. But Coinbase just isn't going to be able to facilitate that many channels. So you need this routing functionality to be set up to allow for people to still transact with Coinbase without directly connecting to them. So kind of in step 2 here, I say Alice wants to pay Carol, but isn't directly connected to Carol because Carol is very popular. Say Carol's Coinbase, and Alice is only connected to Bob, who's connected to Carol. So let's say there's like a liquidity provider that Coinbase is using to service a wider array of their customers. So for Carol to receive payment from Alice, Carol needs to generate a Lightning Network invoice with one of these special hashes embedded inside of the invoice. And what that means in plain English is you can pay me here, and you know the payment was successful if the pre-image to this hash was sent back to you. So that's how this like Lightning Network sets up these incentives, is you pass around these hashes, and that kind of acknowledges that you received a payment. So then Carol, or Coinbase in this case, would give the invoice back to Alice. So going off of our kind of Coinbase example here, Alice would want to be depositing money into Coinbase via the Lightning Network. So again, Coinbase or Carol gives this invoice to Alice. So we've set up how to execute a Lightning payment here. This is like what this slide's all about, is like the process that needs to be taken to actually set up a Lightning Network payment. And now we're going to talk about actually executing that payment. So if we're talking about Bitcoin parlance, this would be the same as like broadcasting a transaction to the blockchain. So to actually execute this Lightning payment, Alice asks Bob if he knows how to solve the hash in the invoice. And Bob's like, no, I don't know how to solve this hash. I don't know what the pre-image to this hash is. But Bob can ask his peers if they know how to solve this hash. So Bob goes and asks Carol or Coinbase, and Bob asks them, like, do you guys know the solution to this hash? And Coinbase says, yes, we do. Like, here's the solution to this hash. And because of the way the HTLCs are structured, that allows Coinbase to claim the money that was locked into that HTLC. So now Coinbase has been compensated the money that Alice wanted to send them. So let's say it was 1 Bitcoin Alice wanted to deposit into Coinbase to trade. But now there's a key part here. Again, this is a routed network. So Coinbase has now claimed that 1 Bitcoin, but Bob still needs to relay that hash back to Alice to be able to claim the money from Alice herself. So there's this kind of like this domino effect here where Coinbase kind of tipped over this first domino and it's like, okay, I've got the money now. But Bob still needs to tip over the domino between him and Alice to be able to claim the money from Alice herself. So that means 1 Bitcoin goes from Bob to Coinbase, and then 1 Bitcoin goes from Alice to Bob. So now Alice has spent 1 Bitcoin, and Coinbase has received 1 Bitcoin, and Bob just relayed 1 Bitcoin. So he still has the same amount of money. That's very important, because otherwise you end up with a little bit of a perverse incentive here where Bob can be cheated. So anyway, talking about old states for Lightning Network transactions, Alice may want to cheat and pretend like she never paid Bob, which is a problem because, like, you know, Bob's kind of doing this service here, and he doesn't want to be out money for helping out Alice, and that obviously isn't what we want to incentivize in the Lightning Network. So how do we make sure that none of these old states where Alice had the 1 Bitcoin and Coinbase didn't have the 1 Bitcoin are kept from the blockchain? We want to make sure that you can't just broadcast an old state that was a better outcome for you. So like in this case, Alice having this 1 Bitcoin is obviously a better state for her, so she can get away with theft. That would make her very happy. So we use these things called penalty transactions to prevent against that. So then, like, what about Bob? Like, what is Bob doing in this scenario? He's just kind of in this middleman that's like routing transactions, and like seems like he's got a lot to lose and not a lot to gain. But the thing with Bob is he can be compensated in routing fees. So these routing fees mean that Bob can charge a baseline fee, let's say 100 Satoshis for every payment that he relays, and then a liquidity fee too. So that means a bigger payment that he relays, he gets paid a higher percentage, just like how Visa charges, 2.5% for a credit card transaction. The bigger that payment is, the more Visa gets paid. There's more smart contracts in Lightning. I'm kind of running out of time here, so I'm going to gloss over this. These are just ways to make sure that people aren't doing bad things. So what my company does, we're a Lightning application company called SuredBits. We offer monetized APIs over the Lightning Network. So we have APIs available for the National Football League, the National Basketball Association, and cryptocurrency exchange APIs for market data. There's some really interesting applications of the Lightning Network that are going to be coming down the pipeline, and one thing that I'm kind of excited about personally is the high-frequency trading / exchanges aspect of this. It's going to be a big deal, and liquidity is going to become a lot better on the cryptocurrency markets in general, in my opinion. And there's 3 implementations of Lightning. You can read about those online if you want. There's problems with Lightning. The routing stuff, the Alice, Bob, and Carol situation we were talking about is still kind of an unknown. We don't know what the fee market's going to look like there. We need to make sure that Bob is getting fairly compensated for his services. There's these watchtower things and backups where if you have an old state of your Lightning Network transaction and it isn't the newest state, you can actually end up losing all of your money. It's a very harsh penalty, and we have protocol enhancements being proposed to fix that, but it's not here today. And your private keys need to be hottish. You need to be online all the time, relaying these payments and signing things. So that's another inherent limitation to Lightning. And yeah, so thanks for letting me come talk to you folks. And I'm Chris Stewart. Got my company SuredBits. If you want to read more about it, you can go to any of those links. And yeah, thanks for letting me talk to you.